Okie dokie. In this problem, they ask kind of the opposite. They say which of the following is an antiderivative of this? Meaning, if we took the derivative of one of these functions, would it give us just ln of x as a result? And so I believe that's the approach in this one. We want to take the derivative of each option until it matches ln of x as its derivative. There's another approach which is a little, it's kind of like too far past what y'all are learning right now, but it's called integration by parts. So if you're curious and want to look that up, feel free, but I don't think it's taught in this course. So let's jump into it. We're starting with a derivative of this first one. So the derivative of minus 1x or minus x is just minus 1 or negative 1. And then with x times ln of x, we need to use the product rule. So jumping into the product rule, the first thing we need is f prime. So that would be the derivative of f, which is x. So the derivative of x is 1. Then we'll do 1 times g, which is ln of x, and then plus f, which is x, times the derivative of g prime, which ln of x has a derivative of 1 over x. That's kind of just a memorized one, so hopefully you'll have that reviewed at this point. So then, what do we have? We have minus 5, and that would go to 0. So any derivative of a constant goes to 0. So this is our derivative of that function. Let's simplify it a little bit. We have minus 1 plus 1 times ln of x is just ln of x. And then x times 1 over x. This is like x over 1 times 1 over x. The x's cancel. And so we're just left with 1 over 1, which is just 1. Negative 1 plus 1 cancel. And so we are left with just ln of x. So actually, this first answer worked out. When we took the derivative of it, we got ln of x, and that's what we are looking for. So just for practice, I might go through maybe, I don't know, 2 more of these real quick. I'm not sure, because actually I did this derivative here, and then ln of x, again, is just 1 over x. I guess just to mention this one, 1 over ln of x, in order to take the derivative of 1 over ln of x, you could either use quotient rule, or you could rewrite it as ln of x to the negative 1 power, because in the denominator, it's basically being raised to the first power. So getting it out of the denominator would be to the negative 1. Then using chain rule, we could bring out the negative 1, leave the ln of x, subtract 1 to get negative 2, and then we'd have to still multiply by the derivative of the inside to get 1 over x. So this is nowhere near ln of x. So just to kind of show an example that does not work, that would be the case there. All right, so same process here. We're going to take some derivatives. I might do us a favor and start with these bottom 2 down here just to shorten the amount of time that it takes. So we are using product rule to find the derivative of these 2 terms being multiplied together. Plus 10, that derivative will go to 0. So if this is f, this is g, f prime to start off with would be the derivative of e to the negative 4x, which is e to the negative 4x, and then times the derivative of the inside. So we're using chain rule. The derivative of negative 4x is negative 4, so this is our f prime. We want g, which is the second piece here. And then using product rule, we have addition of f times g prime. So looking at this whole g set of parentheses here, the derivative of negative x over 4 is the same thing as, this term is the same as negative 1/4 times x. So a constant times x has a derivative that is just that constant. And then 1/16 is just a constant itself, so its derivative goes to 0. So negative 1/4 is the derivative of g altogether. All right, can we simplify this? Let's see what happens. We have negative 1/4 times the e term. And then over here, I might recommend maybe distributing this term to these terms. All right, let's get going. We have negative 4 e to the negative 4x times negative x over 4. Okay. And then we have minus 4e to the negative 4x times negative 1/16. Okay. So let's see what we can do. 4 and 4 can cancel. Which 4s am I talking about? I'm talking about these ones. So 4 on top, 4 on the bottom can go away. The negatives can cancel. They make the whole term positive. So we're left with this e term times x basically. And then over here, 4 can cancel with 16 to leave a 4 on the bottom. In other words, 4 over 16 reduces to 1/4. The negatives can cancel out once again. So we're left with a plus there. And then, oh, what do you know? We have this and this. These are the same terms except one is positive and one is negative. So these cancel out and we are only left with e to the negative 4x times x. That's pretty cool. All right. So I'm not even going to bother working out d. Hopefully this makes some sense altogether. A and B would require product rule as well, a little bit of chain rule, and then D would be very similar to the one we just did. So hopefully that makes sense. Let's go ahead and knock out this last one real quick if we have time. I'll just, we're just gonna, let's just see what the right answer is. And we're gonna work out that derivative just to give you an example because there's no need to try a bunch just to make this video. Okay, so we're doing the derivative of this function. We know the plus 4 goes to 0. This first term has an x term times another x term, 1/2 x times a sine of 2x. So we need to use product rule for this one, but we won't need to use product rule for this term because there's just one x across the entire term. There's not two x's like there are here. X terms multiplied by each other. So starting with product rule, we start with f prime, which is the derivative of 1/2 x. A constant times x has a derivative of just 1/2, or just that constant. So then times g, and then plus f, which is 1/2 x, times g prime, which is the derivative of sine, so cosine, of the same inside, so 2x, that we multiply by the derivative of the inside, which is 2. So the inside, of course, is the 2x here. So this altogether is the product rule for just the first term. So I'm going to simplify this first, then I'll work out the derivative of the plus 1/2. Actually, you know what? No, let's go ahead and find the derivative of the 1/4 cosine of 2x. So 1/4 cosine of 2x would be 1/4. Then cosine has a derivative of negative sine of 2x. And then derivative of 2x is 2. So all together we have this. Let's simplify things along the way. 1/2 and times 2. 1/2 times 2 is 1, so those cancel. And then over here, we have a negative from here, which could just make this a minus. We have a 2 and a 1/4, which can reduce to a 1/2. 2 over 4 is the same as 1 over 2. Let's see what we have. Look at that. We have a 1/2 sign minus a 1/2 sign, so those will cancel, leaving us with just x times cosine of 2x. All right. Hopefully this makes some sense. Again, this is kind of just a lot of practice in product rule and quotient rule. It appears that 311b, these problems are, we mainly use product rule. I don't know if there's quotient rule mixed in or not. But yeah, all right.